That's the beauty of this project, right? And then we're talking about Secrets Store CSI drivers. CSI as an acronym is probably new to a lot of folks. So what CSI is it's Container Storage Interface. That's what it stands for in Kubernetes.
Hello, everyone. We are back here at the Open at Microsoft show with Anish and Ben. Hello, Anish and Ben.
Hello.
I love the background there. We're going to talk about secret management, certificate management, life cycle on Kubernetes. And we have now two maintainers here to talk about this. Tell me, Anish, in a sentence, what secret management on Kubernetes or the native secret management on Kubernetes? Welcome.
Hello. So thank you for having us here. I am going to be talking about Secrets Store CSI Driver, but before we jump into that, let's talk about why do we need external secrets in Kubernetes, right? So you might be thinking Kubernetes already has a built-in secret API. So there is this thing called Kubernetes Secrets. So why not just use that? So there are a few challenges associated with using Kubernetes secrets by default. The secrets are only base 64 encoded when they are stored in etcd. They are not encrypted. So anyone with access to the API or the data store can actually just see them in plain text. So we have this concept of encryption at rest that you can optionally enable in your Kubernetes cluster. And there are like multiple external integrations. So there is a KMS provider for like each cloud provider that you can enable. And at that point, data in etcd is encrypted. But even with encryption at rest enabled, these Kubernetes objects can expand the attack surface. So anyone who has like RBAC permissions, like to be able to see secrets, can actually just see these secrets in plain text. Then the next thing is many organizations have already standardized on external secret managers. It's like Azure Key Vault, AWS Secrets Manager, GCP Secrets Manager. So they want you to use that in your workload, even if your workload is running in Kubernetes. And the last thing is these external systems also bring in like quite a lot of features from cloud providers. So it's things like automatic rotation of secrets on a particular cadence. Then there is auditing. So like who's using the secrets, where is it being accessed, and things like that. Alerting. And then there are tighter integrations with the enterprise side security policies. So the real question comes down to how can Kubernetes workloads safely and easily consume these external secrets without rewriting their applications or having to duplicate these secrets into etcd. So some of the options that were available before, like the project that we are going to talk about, is one, you could modify your existing application to directly call this external secrets API. And that means you have to rewrite your application if you want to use Azure Key Vault or if you want to use GCP Secrets Manager. So there was no one single way to access secrets from different secret stores. And that's a lot of work for anyone who's maintaining an app, right? Then the other option is you can sync these as Kubernetes secrets, but we just talked about how syncing as Kubernetes secrets is not ideal just because anyone in the cluster can easily access it and read it, even if you enable encryption at rest when it's stored in etcd. And the third option that was out in the wild is having something like a sidecar. So sidecar is a container that runs in conjunction with your actual container. And then you can have like init containers too that start up and do a particular job. So you can have a sidecar container that has all these SDK logic that'll go and fetch the secret from external secret store and then make it available for your actual container. But the problem with this approach is you have this additional container that you have to manage. There are like resources around it. And if you have like lots of pods trying to get secrets, you basically have like so many sidecar containers that's running. So all these solutions are doable and they're out there, but none of them are like clean or universal, in my opinion. So that is where the Secrets Store CSI driver comes in. So the Secrets Store CSI driver. Yeah, go ahead.
No, I'm just saying, yeah, before we start, you talk about a few points there. You talk about encryption at rest. You talk about life cycle of the secrets of the certificates, how to manage that. So that specific Kubernetes, what they call special group to inside the Kubernetes project called Secrets Store CSI Driver, kind of manage those all those features. Is that correct?
Yes. That's the beauty of this project, right? And then we're talking about secret source CSI drivers. CSI as an acronym is probably new to a lot of folks. So what CSI is it's container storage interface. That's what it stands for in Kubernetes. And it's basically a Kubernetes standard for mounting volumes into pods via external drivers. And the Secret Store CSI driver project is a special CSI driver designed not for traditional storage, but for mounting secrets or keys or certificates that you have in your external secret store. And to give you a little bit of context on like the history of the project, like this is a project that was its development started in around 2019 as like a proof of concept. It was initially in DS Labs GitHub repo, and what it had was an Azure provider, so it can talk to Azure Key Vault, and then there was also a HashiCorp Vault provider. And then there were a lot of users using it, and it was slowly being used everywhere. And that is when we basically started talking to SIG Auth in Kubernetes. So when I say SIG, it's special interest group, and there is a SIG Auth in Kubernetes. Uh, and we basically presented the solution to them and said, like, this can benefit like the wider ecosystem. So why not have this as a SIG Auth sub project? So that is what it is now. So it's a SIG Auth sub project, and it was originally started in 2019, and it uses the CSI interface to basically mount the secrets, keys, and certs as volumes inside your pod. And what this means is applications get secret as files, so they don't have to do any code changes. They can just have a very simple code to read things from the file system. And if they have to move between different external secret store, they could easily make this happen because they're always reading secrets from the file system. And to dig deeper into like what the driver gives you, right? So it basically mounts secret keys and certs from any external secret provider. And then the data is written into tempfs. So when we say volume and volume mounts, like the concern always is, oh my God, like, are you writing my secret to disk? But that's not really the case. So this is tempfs, so it's ephemeral. And all the secrets are actually written only in memory, and it's never persisted on disk. And the driver also supports a pluggable provider interface. So this is one of the best parts about the a driver as a pluggable architecture. So the driver itself is provider agnostic. So that means it defines an interface that any provider can implement. And today we have about like 7 different providers. So like Keyless, AWS, Azure, Conjure, GCP. And organizations can also write their own custom providers to integrate with these secret stores. And then the flexibility has been the key to adoption across like cloud and all the on-prem environments. And then the other feature is we also support rotation during the pod lifecycle, but you will see it in action and you'll learn more about it as we go further. And it also supports both Linux and Windows workloads. And
That's
then
nice. I think Ben is going to show that for us very soon in a demo, like end to end. But like if I'm a developer, I'm doing my code here locally. I have like an environment variable with my, my secret, my certificate. So like you said, the same thing will be done by the secret store CSI driver. They're going to mount these. They can mount as a file. They can mount as an environment variable as well, I'm assuming.
so it can mount it as a file. And then by default, you cannot do it as an environment variable. But it's relevant that we're talking about it now, right? So in Kubernetes 134, there is actually a feature that landed in alpha that allows you to consume environment variables from files that are mounted. So with basically you can use the driver and this feature that's available out there, and that way you can have environment variables using the Secret Store CSI driver.
Sounds good. Do you want to show like your diagram or pass to Ben?
Yeah, sure. So let me really quick touch on how this whole thing works. Like it's a little complex in terms of how it works, but hopefully we have made it easy for you when you're trying to run it. But what you do as a developer when you're trying to deploy something is you define a pod with a CSI volume that points to the Secret Store CSI driver. So this is your pod. And then the pod gets scheduled onto a node, and kubelet that's running on the node notices that this is a CSI volume. And then kubelet calls the CSI driver defined in the volume. And kubelet knows how to talk to the driver through a CSI driver registration mechanism. And all of this communication is done through Unix domain socket. And then what the driver does is it sets up a tempfs mount, and then based on your configuration, it calls the specific provider that you want to access the external secret store from. And then the provider is the one that's responsible for getting the secrets from external store, so like Azure Key Vault or something, and it sends it back to the driver. And at this point, the driver writes everything into the file system. It's all tempfs. And then finally, your container starts. And from its perspective, all the secrets or certs or keys or everything is available from the file system. So this means there's no SDK changes, no sidecars, no secrets persisted in etcd. And the way the configuration is done is through two different custom resources. And custom resources is a way in Kubernetes to basically extend configuring things that you want or setting things up, right? So each project could have its own custom resource definition, and you would create an instance of that. And in this case, there is one custom resource that you as a user would create, which is called the secret provider class. And you will learn more about it during the demo. And there is another custom resource called secret provider class pod status, which the driver generates. And again, you will see that in action when Ben does the demo. So now that we've given you an overview, what I'm going to do is let Ben show you a demo of the driver in action and stay till the end because we're going to talk about all the future work that we're doing.
That sounds good. That was a great overview. Thanks, Anish, for that. Just like recap here before you go for Ben, like if you're a developer, you develop an application and you need secrets, and like let's say you work on Azure or any other cloud providers, and you wanted to mount your secret, your certificate for your application, that specific project mounts as a file. And now Ben is going to show how that magic works. You don't have to install these things that's coming like out of the box on most of the Kubernetes distributions out there, including Azure Kubernetes Service. So the only thing you have to do, Ben, tell us how easy it is to use, and you don't have to understand how the project was done. Unless if you want to help the project, you're going to see at the end how you can contribute to the project. Well, let's go. Welcome, Ben.
All right. Yeah, let's share my screen. There we go. Yeah, again, so I'm going to go show the Secrets Store CSI Driver running in an AKS cluster because we are here at Microsoft, so that makes sense. Utilizing an Azure Key Vault to hold a secret, just some plain text thing I'm going to have in there. And we're going to sync that from the Key Vault all the way into a workload running on this AKS cluster directly into the pod, right? Directly into that workload. I'm going to try to cover, I'll try to explain the details as we go, maybe cover some of the security principles, assume the audience is not a security expert. So hopefully we're making this more easy to digest in Grok for whoever is watching. So they get the value and understand like, it is more stuff to set up front. Sure, there is that pain, but I think the benefits are great. And so hopefully we can convince you of that. So first thing first, I'm going to show that I have a key vault. So I've already created this, so we'll just show that quick. And I have a secret in that key vault. And the value of the secret is just, extra secret stuff don't share. Nothing important, right? Here's a string, but it could be anything. It could be you put certificates, you can put, all kinds of stuff, app keys, whatever. Doesn't matter. But for this demo, this is what I have. And then I have an AKS cluster here, and we can show that. And then, of course, we need to know if the CSI driver is running on this cluster, which it is here, as well as the provider for Azure. And that provider for Azure is what's going to help us talk to the Key Vault to go get that secret, just this one for this demo, and put it into our one pod. really great when you're actually expanding to more secrets or many, many, many pods. I'm going to show you, especially when we get into like rotation and things, how that's going to be really beneficial and takes the weight off later when you're trying to rotate secrets is a good thing. Keep short-lived secrets rather than long-lived secrets, etc. Um, okay.
Oh, Ben, just a question there. Like someone watching, normally when you create a cluster, those CSI drivers, they are installed and maintained by the Azure Kubernetes service specifically. You don't have to do much when you create a cluster to have those CSI drivers installed, correct?
This here is the Secret Store CSI driver, so you won't get this out of the box. You'd have to install this, but we have Helm charts and things on the repository that Anish showed earlier. You went to the documentation page, but that would link you out to the GitHub repo, which will have kind of all the things that you need if you want to see how that goes. If you're using AKS, like Microsoft, since we're talking about it, AKS does have the option to provide a flag to the CLI, and you can spin up a cluster that is already up and running with all of this for you. So that's a convenient thing. Other cloud providers may or may not do, their own things. Keep it kind of tight. I won't talk to all of that, but yeah, in this case, this is running now because I did actually run that AKS CLI command and ask for the CSI driver to be installed for me, as well as the provider, and we can keep rolling along with that. Does that cover your question?
Sounds good. Yeah, sounds great. Sounds great. That's it.
Okay. I'm going to run this next command real quick. This I'm going to briefly touch on. Ooh, that's really big. So let's shrink that down maybe quick so you can see a little bit more like a table. I'll grow it back up, hopefully, so you don't have to squint. But one other thing that we cover here is that third line. This is get the CSI drivers. The third one is the Secret Store CSI driver. And you can see in column 1, 2, 3, 4, 5 is token requests. And at the bottom, it says Azure AD token exchange. We want to briefly cover this too. The provider provides, the CSI driver and provider provides the ability to sync tokens from, external secret stores. And also via this, we can utilize like workload identity, and we can do a workload identity federation. In this case, we would be teaching Entra ID, since we're running an AKS, how to trust tokens that are issued by the Kubernetes cluster, this AKS cluster, for this provider, so that it can trust that token and exchange that token from that service account that represents that pod for an access token for that key vault, which then means you can set up Azure RBAC to limit the access of workloads accessing that key vault. So there's just a lot of ways that you can get a lot of security benefits out of this project. I'm not going to go too much further into that because workload identity is a whole nother big thing. But I figured I would show it real fast because it's valuable and could be good for a future episode to go more into those kinds of details. Sure. So I'm going to keep rolling and hit the secret provider class. Like Anish mentioned earlier, the secret provider class is the object that is going to kind of marry up the pod later with the specific secret and the specific key vault that we want to get. So you can see under that spec, providers Azure, that's where we're at. Further down, the key vault name is AKV Demo 06. That just happens to be what I called it. And one object from there, our super secret -1, is the secret that we want. So we will create that on our cluster. And then need a service account for this pod. Create that, and then make our pod. Now, our pod here is going to be where we reference that secret provider class that I showed you just a second ago. If you go all the way to the bottom, right, this volumes is going to list out one called Secret Store Inline. It has a CSI driver reference for Secret Store CSI driver. And in the volume attributes, we have secret provider class as a name. CSI-SPC is what we named it. So we're going to reference that. And then the volume mount under the spec, under the containers, right, is where we're going to call it Secret Store Inline again. And we'll give it a mount path. So when the kubelet, when the node gets this pod scheduled, the kubelet's going to say, okay, this pod is expecting this particular secret provider class, this particular secret to be mounted, or this volume to be mounted, utilizing this CSI driver. It's going to go then talk to the provider, do that exchange, because I did set up workload identity and RBAC and everything. So it's going to do that exchange for that token to get an access token to go get that secret from that key vault, bring it back. And when it creates that pod, it's going to write that secret to a text, to a file in an ephemeral volume, in TempFS, like Anish said earlier. And it's going to do that right now. It's going to be pretty fast, but that's actually a lot of steps that are going on behind the scenes there, right? And as long as that pod is created, which it is, and it seems to be happy, we can take a look at the logs and see that, hey, look, extra secret stuff, don't share is written in there. Now, normally we would say, do not write your secrets to the logs. That's a bad idea, right? We want to keep those here. The whole point of all this is to security best practices. Not logging secrets to logs is a good idea, but for this demo, I did that. We're going to look quick at the volume mount itself. So we can see that volume mount, that file in there, does actually have that text file. So that's cool. That's what we're expecting. And we can also check the type of volume mount, executing into the pod each of these times, right? Then check in the mount grep for Mount Secret Store and see that TempFS on Mount Secret Store, type TempFS, yada, yada. So as Anish said, this isn't written to disk. It's not written to etcd via like a Kubernetes secret proper. It's ephemeral. It's going to exist as long as the pod exists in memory. When the pod's destroyed, this is going to get destroyed as well. So that's nice because it's going to narrow down the access to that, right? The only thing that can access the secret now is this pod, and you can only get at it if you can exec into the pod. And most people these days are using, distroless or Scratch or something as a base image, which doesn't really even give you much for tools to get at things. So if a bad actor was trying to access that workload, nowadays that even would be a difficult vector to approach to try to get at this secret. So that's a good thing, right? Now I mentioned we would be doing some rotations.
Yeah, that's a $1 million question, Ben. Now my application is running inside that pod, and now we want to rotate. We want to create a new version of that secret. How that work? How that magic works?
Yeah.
You don't have to stop my pod. The pod's still running.
Well, it depends. Our pod that I'm showing here does watch the file system. So when the CSI driver writes that file again or updates that file, this workload happens to be paying attention and go, oh, here's new information. Here's the new file. I will read that out and log it again. If yours isn't, right, if you have an older workload of some kind, you may have to go figure out how to approach that. This here is one thing that might help you. We talked about the secret provider class pod status. So let me quick show that really fast before I go and actually do the rotation. But this was one more thing that we wanted to show. The secret provider class pod status. For every single pod that's referencing a secret provider class, there's a secret provider class pod status that's going to kind of be paired up for it to show how what's the state of this, right? And if you look at the status on this status object, all kinds of words using status, but you can see the mounted is true. The object was with the ID of super secret 1 is in there, and there's a version on that. That's helpful. So we can see that this is the version. The pod name was CSI pod. That's the name of our pod. And the secret provider class name is CSI SPC. So you can kind of see all the things that you're expecting seem to work out. There's an owner reference to the pod for this. So when later I also rotate the secret, you're going to see all of these values update. The generation and resource version and stuff will bump. That's all for Kubernetes bookkeeping of this resource, but the status object and whatnot in that version is what's going to tell you that the secret that was mounted or synced from our key vault is also updated, right? So let's finally do that. I'm gonna run a command here that's going to change the value of the secret just to rotate an exclamation point. And that's good. I'll give it just a second and then go hit our logs again. And we should see a second line, which is rotated, right? The old value of the secret that is still there as the first line. The second line is rotated. That's the new value of the secret. How do we know that it's not that both don't exist and that we just have the one new secret that's been updated in place? Well, we can go back to what we did before. We can exec into the pod, check that file, and see that its values changed to rotated. And we can also check the secret provider class pod status again and see that version is different that version ID ended with a couple different characters last time. I forget what they were, but we could scroll up and see that's not the same. You can also look at metadata generation 2. So you can see, well, at least this whole file changed, but also under the status objects, the version has changed as well. So we have a new secret that was passed directly to our workload, right? And that's what we're after. And that's more or less the end of the demo, provided that you don't have questions to tease out anything that we may have glossed over, anything I might have missed. Definitely open to that at this point.
No, I think it's great. I think you saw all the life cycle that Anish was showing there at the beginning, and you saw the rotation at the end. And the only difference is sometimes you have a deployment and not like just deploy a single pod. You have a deployment, but it's going to work, I'm assuming, the same way with a deployment.
Mhm.
Then I just want to see if you go back, Ben, to Anish, and then show what's next. What's next on, and how people can contribute to this project. And Anish, tell me how people can help,
Yeah.
how
So
the community can help the project.
So to very briefly cover on what we're doing, so we talked about rotation, and the way rotation is implemented is we have a rotation reconciler in the driver. So all this complexity is handled in the driver, but in the Kubernetes community, the CSI interface has actually been enhanced since 121 to add this new thing called requires republish. So you can basically enable that feature, which will make the kubelet call the driver periodically and say like, hey, you mounted something last time. Can you check if everything is fine? And if it is, basically tell me it's okay. So we can piggyback on that feature, which means we can drop a lot of the RBAC permissions that's required by the driver. So that's what we're working on. It's a big change. We are very close to landing that. And then the next thing is file system permissions. So by default, the files that get written require you to have your binary to have root access. But instead of that, what we're trying to do is basically funnel in the file system group that you define on your pod spec and have that at the driver and decide what permissions are required for accessing these files. So we have a proposal for that. We are working on all of that. And then the third thing is, so we talked a lot about Secrets Store CSI Driver, why Kubernetes secrets are bad, but we also understand that you might still need Kubernetes secrets. And the reason for that is things like ingress controller, which need you to define certificates as TLS Kubernetes secrets. So we have had a lot of users ask us about it. And that is where now we have started a different sub project, which is called Secret Store Sync Controller. It's in pre-alpha. This is also a SIG Auth sub-project. And the reason it's a SIG Auth sub-project is it uses a lot of the primitives that we already have in the driver. So basically, any provider that works with the driver today will work in the sync controller scenario. You will be able to reuse your existing secret provider class. And then there is another custom resource called Secret Sync that you configure. And the beauty of it is it works with workload identity. So if your cloud provider supports workload identity, you still can have individual identities to access these external secret stores rather than having that one single controller being able to have access to every single secret store. And in terms of contributing, so there are these two projects. And if you're interested in contributing, these are ways you can help. So we have a Slack channel, so you can join that Slack channel and reach out to us. We have bi-weekly community meetings on Thursdays at 9 a.m. PST. And in terms of GitHub issues, we have a couple of good first issues. So you can basically browse our issues and reach out to us if there are any things that you want to work on. And there are like active pull requests that you can also help review. So we would love for you all to try it out, both the projects, and then join the community and help us shape the future of secret management in Kubernetes.
That sounds great. I love it. How deep we went on the subject. Thanks a lot for the explanation, the deep dive demo. And please help the community. And if you like, the show, leave a like, leave a comment for the guys, leave a comment for the project. And I style the project is more important. They want to make sure that they are on the right direction. And if you like, leave your comment and your star. Thank Anish, thank Ben. Really appreciate your time. And see you all next time.